Welcome to The World in 30 Seconds, where we explore the fascinating science behind our everyday lives. Today, we're diving into a biological connection that literally lasts a lifetime, a phenomenon that might make you rethink the very essence of motherhood. What if I told you that a part of your child could live within you, not just in your heart, but in your very cells, for decades after they've grown up and moved out? To help us unravel this incredible biological mystery, we have Dr. Anya, a leading immunologist and researcher whose groundbreaking work has illuminated the intricate ways mothers and children remain connected long after birth. Dr. Sharma, welcome.
Thank you for having me, Lucy. It's a pleasure to be here.
Dr. Sharma, this concept of fetal microchimerism sounds like something out of science fiction. Can you break down what it actually is for us?
Absolutely. Fetal microchimerism, or FMC, refers to the presence of fetal cells within the maternal body and conversely, maternal cells within the fetal body that persist long after pregnancy. Think of it as a microscopic exchange of cellular souvenirs that can linger for years, even decades.
Cells lingering for decades? That's astonishing. So it's not just a temporary biological event during pregnancy.
While the most intense exchange happens during gestation and childbirth, studies have shown these fetal cells can be found in a mother's blood, bone marrow, skin, and even her brain, sometimes for 20 years or more. It's a remarkable testament to the enduring biological link.
And what about the other way round? Do maternal cells stay with the child?
Yes, that happens too, though research is still exploring its full implications. The focus has largely been on fetal cells in the mother because their persistence and potential roles have been more extensively studied.
So these fetal cells are essentially tiny immigrants in the mother's body. What are they doing there? Are they just freeloading, or do they have a purpose?
That's the million-dollar question, and it's an area of active research. One leading hypothesis is that these fetal cells might play a role in tissue repair. Imagine a mother's body sustaining an injury. These fetal cells, genetically distinct yet familiar, could potentially migrate to the damaged area and help with regeneration. It's like having a tiny built-in repair crew.
That's a fascinating idea. So a mother's body could be healing itself with a little help from her offspring.
Precisely. Studies have observed fetal cells in areas of maternal tissue damage, suggesting this reparative role. It's a beautiful example of how our bodies are incredibly complex and interconnected systems.
It makes you wonder if there are any downsides to this cellular cohabitation.
Generally, the presence of fetal cells is considered benign and in many cases beneficial. However, like any biological interaction, there can be complexities. For instance, there's ongoing research into whether FMC might play a role in autoimmune diseases, though the evidence is still being gathered and is not conclusive.
So it's not like your child is secretly taking over your body's steering wheel?
No, not at all. It's more of a subtle, supportive presence. More like a long-term, microscopic house guest who occasionally pitches in with chores.
That's a great analogy. I can just picture it now. So if these cells are there for so long, does the number of children a mother has influence the extent of microchimerism?
That's a logical question. While it's not a simple one-to-one correlation, having more pregnancies does increase the likelihood of fetal cells persisting in the mother's body. Each pregnancy is an opportunity for this cellular exchange.
This is truly mind-blowing, Dr. Sharma. It adds a whole new dimension to the maternal bond.
It really does. It's a physical manifestation of that deep biological connection that extends far beyond the 9 months of pregnancy. It's a lifelong partnership at a cellular level.
So the key takeaway today is that the bond between a mother and her child is not just emotional or genetic, but a tangible cellular connection that can persist throughout a lifetime. Thank you, Dr. Anya Sharma, for sharing your incredible insights with us. And thank you, listeners, for joining us on The World in 30 Seconds. Don't forget to follow us on Spotify for more editorial content that is out of this world. You can also find us on Instagram, Facebook, and LinkedIn.